Hello and welcome back to your channel Physics Safari. My name is Abhishek and this is the third video lesson on the work energy power. In the first video, I have spoken about the basic fundamental of the work. Second, we have done some questions and on the constant force. And today, I'm going to discuss with you the work done by the variable forces. Now, when we talk about the variable forces, this could happen because of two reasons. One based on the time changes and other based on the distance changes. So let me quickly talk about this. The force can vary with time or it can vary with the distance or displacement. जो भी आपकी मर्जी है ना जी. So we're gonna see both the cases ki how to deal with the question in which the forces vary with the time and also in the situations when the forces vary with the distance. Now, how it becomes different from the normal questions when we do not have anything as such where the force is changing. In that cases, we can simply use the work is equals to Fs, as simple as that, or F dot S based on the angles. But in this case, we have to use the concept of integration because already I have told you that when we have the variable forces, we need to understand that it will change with time or with the distance. अगर वो चेंज हो रहा है डिस्टेंस या टाइम के साथ देन वी हैव टू फाइंड द वर्क डन विद द न्यू फोर्स बिकॉज इट इज चेंजिंग ऑल द टाइम है ना. तो इंटीग्रेशन इज गोइंग टू हेल्प यू ऑन दैट. कुछ प्रॉब्लम्स करते हैं दैट विल डेफिनेटली हेल्प यू टू अंडरस्टैंड दिस कॉन्सेप्ट और इसके बाद हम लोग चलेंगे वर्क एनर्जी थ्योरम पे. ठीक है जी. तो फटाफट एक क्वेश्चन से स्टार्ट करते हैं. आई एम गोइंग टू टेल यू व्हाट एंड हाउ टू अप्रोच फॉर अ पर्टिकुलर टाइप ऑफ प्रॉब्लम. कैसे इसको अप्रोच किया जाए हम लोग उस पर ज्यादा फोकस करेंगे ना. चलो एक सिंपल प्रॉब्लम से स्टार्ट करते हैं. लेट अस से दैट द फोर्स ऑन एनी ऑब्जेक्ट, द फोर्स एक्टिंग ऑन एन ऑब्जेक्ट इज गिवन एज a plus bx. ऐसा कोई फोर्स है ना. Now this force depends, as you can see, on the value of the x. It depends upon the value of x, where a and b are the constant. The force would vary with x. Now I'm asking you, find the work done. Find work done when the object moves from x1 to x2. This is a general term, like कुछ भी आप ले सकते हो 2, 3, 5 जो भी हो. I'm just giving you a very general understanding कि अगर x change होता है from x1 to x2, what is going to be the work done, है ना जी. देखो बड़ा सिंपल सा प्रोसेस है इस केस में. I'm going to find the elementary work done. Elementary work done should be how much? F dot dx. Because what is variable here? X is variable. तो सिर्फ हम लोग x को लेंगे. मान लो कि बॉडी x डायरेक्शन में मूव कर रहा है ना. Let's suppose the object जो है वो x डायरेक्शन में मूव कर रहा है. Because there is no change in the y, उसका अलग केस है, उसको हम डिस्कस भी करेंगे. आई थिंक प्रीवियस वीडियो में मैंने एक क्वेश्चन आपको बताया था. Let us suppose the body is moving under this force along the x axis. तो only variable what we have is x. x चेंज कर रहा होगा एंड अलोंग विद दैट चेंज फोर्स भी आपका चेंज करेगा. तो दिस इज योर एलिमेंट्री वर्क डन. अब मेरे को टोटल वर्क डन निकालना है. टोटल वर्क डन इफ आई वांट टू फाइंड आई जस्ट नीड टू इंटीग्रेट दिस dw which in turn would help me to integrate this and the limit of x is going to be from x1 to x2. कोई बड़ी बात है नहीं जी, है ना. चलो अब क्या ही बचा है. अब तो सिंपल इसका वैल्यू पुट करके इंटीग्रेशन कर दो. फोर्स इज हाउ मच? a plus b times of x इंटीग्रेशन dx from x1 to x2. ठीक है जी. तो दिस इज गोइंग टू बी ax plus bx square upon 2 and the limit is going to be from x1 to x2. All okay? Great. Now the next step should be you're going to put the values of the limits. So that should be a x2 and plus b x2 whole square upon 2 and you put the lower limit that is x1. So yeah, so it's going to be how much? ax1 plus bx1 upon 2 whole, like this square, na? All good. Now let us take the common out. I think we can just do like this. We can have x2 minus x1 and plus b upon 2. I could have x2 square minus x1 square. You can actually simplify this one more step. आप इसको एक और स्टेप सिंप्लीफाई कर सकते हो. यूजिंग a square minus b square is going to be a plus b times a minus b. So if I do that, I should be having what? x2 minus x1 plus b upon 2. This could be written as x2 plus x1 times of x2 minus x1, which Later on, we can take out one common, one step this factor common, and I should be having just a plus b upon 2 times x2 plus x1. Well, this is the work done by this force when the object moves from x1 to x2. I believe this should be okay to all of you. किसी को doubt है तो let me know. I'm going to help you on that. And if it is all good, do make a note of this one. And then we should go on with the next problem. हम लोग एक और problem करते हैं. All good? Now let's say question number 2. I say that there is a block which is kept. एक block है. There is a block which is kept on a surface which has a certain amount of friction. So there is a frictional, it's a rough surface, and the coefficient of friction of between this surface and the block is given as mu. Let's suppose mass of the block is taken as m. Now this block is moved by a force, let's suppose acting in the rightward direction, and the block would start moving. Now my question to you could be of various type. Type part 1 could be find the work done by the force in certain time, find the work done by the frictional force in certain time, find the work done by the gravity in certain time, find the work done by the normal reaction in certain time. I could also ask you find the total work done, and the last one could be find the velocity of the object in certain time. These could be the few variations of the questions over here ना. इसके कुछ 2-3 variations हो सकते हैं. All good? या फिर इसको भी रहने दो, let it be, because I'm going to use this in the after I teach you the work energy theorem. वर्क एनर्जी थ्योरम कराने के बाद इसको मैं यूज करूंगा. अभी एक और दूसरा क्वेश्चन कर लेते हैं. Let us see that a displacement of an object is given as 1/3 t to the power of 3, and the mass of the block, let us say, that is 1 kg. And this is happening of course under the influence of a certain force. एक force के अंदर influence हो रहा है, काम हो रहा है. You have to tell me find the work done during 1 second. Find the work done during 1 second. So essentially the thing is there is a block which is moving and its distance depends upon the time. So let us suppose it is moving and its distance depends upon time. Its mass is equals to 1 kg. You have to find the work done in t is equals to 1 second. You have to find the work done in t is equals to 1 second. All good? Chalo. Now let us try this out. इसको करते हैं ना जी. So now you can see that over here the body's position is not changing uniformly. वो time पे depend करता है. That is depending upon the time. So in time t is equals to 1 second, it is going to be how much? 1/3 meter. But in time t is equals to 2 seconds, that is going to be 4/3 meter. Which means the distance or displacement is not uniform. वो uniform नहीं है. That clearly indicates that there must be some change in the velocity, which means we should be having some sort of acceleration. इसमें कुछ acceleration होगा, इसका मतलब force है. And under that influence of that force, the body is moving. It means कुछ न कुछ work done होगा उस force के द्वारा, and that is what we are going to find. All okay? So let us try and solve it. इसको solve करते हैं. Okay, we need to understand one thing. If x is given as 1/3 t to the power of 3. So if I want to find the velocity, I just need to do dx upon dt. That is going to be how much? 3t square upon 3. It's going to be t square. So we have the function of velocity as a function of time t. In the kinematics I've taught you that only what we have is 6 relations. x t v t a t x a v a और हमारा xv में काम होता है, and we can manipulate, we can form 30 such relations with those 6 relations और हमारा काम होता है. तो this vt is given now. You can also find the value of a. A is how much? dv upon dt, and dv upon dt should be how much? 2t. That means the acceleration of this block is going to be 2t. Now since we have the acceleration, that clearly means we must be having force. हमारे पास force भी होगा जी. अच्छी बात है. Now what we do know is, let us find a small work done in small time dt. We're gonna find a small work done is in small time dt. So dw should be how much? F dot dx. Now since x is a function of time t, you should try and write it in the terms of t. आपको t के टर्म में लिखना होगा. F is a function of time t because force is what? Mass into acceleration. Force is equals to mass into acceleration. Mass we have taken as 1 kg. That clearly means the force of this block is going to be how much? 2t. The force is going to be 2t. I got the value of force in terms of 2t. What next we need is, we must get the value of dx in terms of t. We should get that in terms of t. All okay. We're going to use this one. We are going to use this one because that is somehow relating x and t. Can I say it from here? Can I say it from here that dx has to be t square dt. Dx should be equals to t square times of dt. Well, that takes me to the fact that dw could be written as f is 2t, dx could be written as t square dt. I think we are now going good. We are on the track. Now we need to find the work done. We need to find the work done. So the work done, bacho, that is going to be integration of this small dw. So from here I can take this value of dw. That is going to be how much? 2t cube. So that should be 2t cube dt. Integration from where to where? Time t is equals to 1 second. So 0 to 1 should be the limit without any doubt. This is going to be how much? 2 upon, okay, we have to integrate first. My bad. We're going to do what? 2 to the power of 4 upon 4. Put the limits from 0 to 1. Okay, chalo, let's do it here. That should be how much? Tick, tick, tick. We should be having t to the power of 4 upon 2, and the limit is going to be from 0 to 1. That is going to be how much? 1 upon 2 minus 0. So the work done should be 0.5 joule. The work done in this time is 0.5 joule. Correct? Any doubt? Anyone? I believe ये आपको clear होगा. इसमें कुछ भी doubt होने का कोई chances नहीं है. What we did is, we find the work. To find the work, we found the v in terms of t. We found the a in terms of t, which eventually gave you the f in terms of t, and also we got the value of dx in terms of t. अपने को यहाँ से dx in terms of t we have got, and then we put in we found a small work done, and then we integrated that for the entire work done for the given time period, and we could easily get it done. है ना जी? Okay. Now quickly note it down, and हम लोग आगे बढ़ेंगे. Note it down, and then we're gonna move further. Okay, all good. I believe you guys have noted it down. All right then, let's quickly move on to the next question. I'm going to try and do as many questions as possible in this given less time of frame. Right? Okay. Now let us say that if I give you a force, that would be given as, let's suppose 3x I cap plus 4j cap. That is the value of the force. That is the value of the force. Now, under the influence of this force, let's suppose the object moved from point A to point B, and if I look at the coordinates of point A, let's say that is 2, 3, 2, 3, 5, and point B, let us say if I take 2, 1, 3, 0, and let's suppose 7. The object is moving from point A to point B under the influence of this force 3xi plus 4j cap. You have to find the work done. You have to find the work done by this force. Find the work done by this force in moving the object from point A to point B. All good? Okay. Now, in this case, you can see the value of force is somewhat dependent upon the x. X change हो रहा है, तो force भी change हो रहा है. So again, it is a case of variable force. Now, whenever we have the variable force or x change हो रहा है, force is dependent upon x, उस केस में आपका जो यूनिटरी मेथड्स हम लोग वर्क करते हैं, एलिमेंट्री मेथड, एलिमेंट्री डिस्प्लेसमेंट जो आप लोग है, that should be taken as dx I cap plus dy j cap. And if we have z variable also involved, then I'm going to take dx I cap, dy j cap, and dz k cap. But over here, the force is somehow dependent only upon x, तो हमारा इससे भी काम हो जाएगा. But yes, the force is there also in terms of constant force is there in the y direction. So we have to include the change in the y coordinates as well. Though the force is only dependent upon the x coordinate, it is irrelevant of the y coordinate because we do not have any y variable here. यहाँ पे कोई भी y का variables बच्चों नहीं है. So in the y direction the force value is constant, which is a 4 Newton. So still even if the constant force is there, हमारा displacement होगा ही. So we have to take the displacement vector as your, let's say, ds vector as dx I cap plus dy j cap. Okay, the process is going to be still again the same, very much same. I'm going to find elementary work done. That should be given as f dot ds. All good. And then we're going to integrate this to find the total work done. All good. Now let's say what is the value of the force. Force is given as 3x I cap plus 4j cap, my dear kids, and the dx is given as, you need to put dx I cap plus dy j cap. Well, this step is kind of important. You should not forget this. अगर ये भूलते हो तो थोड़ा सा अटक जाओगे. So make sure that you do understand this. Do practice it for 2-3 times. Okay, one suggestion to all of you: if you guys get stuck in certain questions and you find it damn good or difficult, आप उसको 2-3 बार प्रैक्टिस करो. याद रखना, अच्छे चीज डिफिकल्ट होते हैं. The good things comes with the higher difficulty level, and we have two kind of people. One are those who would just skip that. Okay, it's damn difficult, forget it, भूल जाओ, मुश्किल है, नहीं बनेगा, क्यों टाइम वेस्ट करना, छोड़ दो. और दूसरे लोग जो सक्सेस करते हैं, they believe okay, it is a good question, it is a difficult one, it means I have to give more input. हम इससे ज्यादा सीखेंगे और ज्यादा मेहनत करके उसको सीखते हैं. वो उसको स्किप नहीं करते हैं, लाइक द स्किप बटन नहीं दबाते हैं. दे डू लर्न इट. हाँ, इन्वेस्टमेंट टाइम का ज्यादा होगा, तो डोंट वरी, आपका जो रिजल्ट होगा उसी के प्रोपोर्शनेट होगा. You will be getting a better reward for your higher hard work. So please do not get scared and do not skip. Make sure you do try that. Try करना, नहीं छोड़ना अपने को. All good? Now the next step is I'm going to just integrate this. So quite easy to do. X terms we should keep with the x parameters, and the y terms should be kept with the y parameters. So here I should be having what? 3x dx I dot I goes 0 dot कर देते हैं for your happiness, and this is going to be 4 dy. Now the next step is very important to apply the limits, and then that should be taken care from this part. As you all can see, the x changed from where to where? From 2 to 3. 2 से 3 हो गया x. So then initial limit, lower limit should be 2, upper limit should be 3, and the y changes from where to where? 3 to 0. 3 to 0. Okay, do not get scared, do not get intimidated by appearance of this upper limit कि 0 हो गया सर अब तो लंका लग जाएगी, वैसा कुछ नहीं है. Don't be scared. All good. Okay. Next step again, it's mathematics. There is nothing much about the physics now. So 3x square upon 2. You should put the limits from 2 to 3, and this should be 4 times of x. My bad, it should be y. Okay, and this is gonna be 3 to 0. Going further, 9 upon 9 times 3 is 27. 27 upon 2. I'm just putting it directly. Okay, आप लोग इसको कर लेना, मैं डायरेक्टली लिख दे रहा हूँ. 2 4 4 2 गया खत्म. 6. This is a minus 6. All good. Okay, please don't get mistaken over here. Upper limit is 0, so this is gonna be 0. So plus 0 times minus 12. Minus 12, huh? I believe this is coming under the camera. So it's going to be how much? 12, 27 minus 15 plus 15 upon 2, and this is going to be minus 12. So 15 upon 2 is how much? 7 upon 7.5 minus 12 is going to be 4.5 with a negative sign. So negative 4.5 joule is the work done. I believe you guys can easily crack it. आप इसको solve कर सकते हो, कोई बहुत ज़्यादा मुश्किल calculations नहीं है. All good. ठीक है जी. So this is how we do the work. We solve the questions of the work done in this category. Clear? चलो. Now we're gonna move towards the next part of it. अब हम लोग एक और question करते हैं. एक और question करते हैं. Let's say question number 4 हो गया ना? हाँ. Let's say I have a table and some, you can say, a chain is placed on the table in such a fashion that certain part of it is hanging below. Certain part of it is hanging below. Let's say mass of the entire chain is m, and the length is L. Length of the entire chain is L. Also, it is given that this part which is hanging downward is 1 upon nth times of the total length. 1 upon nth time of the total length is hanging below. All good? So 1, 1th upon nth is hanging below. Let's say we have applied a force in this direction such that it pulls the chain slowly. Force pulls the chain slowly, and when I say slowly, that means there is no acceleration. It just managed to counter the opposing force, and over here the opposing force is gravity. Force pulls the chain slowly against gravity. चलो इसको लिख देते हैं, against gravity. So find the work done. The question to you is find the work done. Find the work done in pulling the entire chain. In pulling the entire chain. In pulling the entire chain up the table. पूरा का पूरा चेन ऊपर लाने में कितना वर्क करना होगा by this force against the gravity, of course, because gravity is pulling it down and the force is pulling it up the table. You have to find how much work is done in pulling the entire chain which was hanging before. ठीक है जी, pause the video and try it, and then you're gonna unpause the video and we're gonna do it together. हम लोग इसको साथ में करेंगे. All good? Fair enough. I believe you guys must have given it a try. आपने इसको try कर लिया होगा. Okay, so this is the case of a continuous body where the mass is distributed uniformly throughout the length. तो इसमें एक टर्म को हम लोग इंट्रोड्यूस कर सकते हैं, mass density, like or mass per unit length. We can actually introduce mass per unit length. Mass per unit length. Like in 1 unit, how much mass is included? That is what we can describe now. So usko we can write, let's suppose total mass is m and L is the length. So this is the mass per unit length. You can represent this with your lambda. It's completely upon you. आपको चाहो तो अल्फा बीटा गामा आपकी जो मर्जी हो आप उसको यूज कर सकते हो. मैंने जस्ट फॉर द रेफरेंस मैंने लैम्डा ले लिया है, which is going to be m upon L. You need to understand when you pull it up, इसको जब ऊपर खींचते हो तो this mass which is hanging would change. और मास चेंज हो रहा है ना जी, तो इसका फोर्स ऑफ ग्रेविटी ऑन दिस विल आल्सो चेंज, क्योंकि ग्रेविटी इस पे भी लग रहा है बट दैट इज नॉट इन द हॉरिजॉन्टल डायरेक्शन. उसको हमको हॉरिजॉन्टली खींचने में कोई भी दिक्कत नहीं हो रही है. द ओनली थिंग व्हाई वी नीड द फोर्स इज बिकॉज ऑफ द फोर्स, द वेट ऑफ दिस पार्ट ऑफ द चेन. वेट ऑफ दिस पार्ट ऑफ चेन इज समथिंग व्हिच वी नीड टू बी पुल्ड अप. ओके, मेरा कहने का मतलब है कि जैसे जैसे ऊपर जाएगा इसका मास, रिमेनिंग मास वुड डिक्रीज, और रिमेनिंग मास हैंगिंग डिक्रीज करेगा तो वेट वुड आल्सो डिक्रीज एंड हेंस द फोर्स रिक्वायरमेंट होगा वो भी कम जाएगा. तो इनडायरेक्टली दिस इज द फोर्स व्हिच डिपेंड्स अपॉन द लेंथ, है ना जी. तो इफ इट इज दैट केस, इट्स अ केस ऑफ वेरिएबल फोर्स. एक वेरिएबल फोर्स का केस है, हम लोग इसको उसी तरह से इंटीग्रेशन लगाकर ही करेंगे. Rule number 1, what you can do is you can choose a small element because to solve it आपको elementary work done निकालना होगा, फिर इसको आपको इंटीग्रेट करना है. ये हमारा बेसिक फंडामेंटल प्रोसेस है बच्चों. So let us say this is small length of it. Let's say क्योंकि वर्टिकल में तो dy ले लो, that's a normal nomenclature we follow. So lambda हमने ले लिया m upon L, इसमें आपको कोई भी दिक्कत होनी नहीं चाहिए ना. ठीक है जी. अभी देखो, in this case what is the weight of this hanging block? इसका जो हैंगिंग चेन, सॉरी, इसका जो वेट होगा वो कितना होगा. तो एंड इफ आई से दैट ऊपर जा रहा है dy, आपको ऊपर की ओर जा रहा है ना, तो बड़ा सिंपल सी बात है कि dy ऊपर जा रहा है तो जो लेंथ है y वो डिक्रीज हो रहा है. अच्छा, सिंस आई हैव टेकन दिस एज dy, तो एक काम करो, इस लेंथ को व्हिच इज हैंगिंग इसको y मान लो. दिस इट इज हैंगिंग लेंथ इज y. तो जो फोर्स होगा बच्चों, द फोर्स which is applied on this, the force of gravity जिस पे लग रहा होगा, that should be how much? इसका m, मास कितना हो गया आपका m upon L into y, because total length is y, इतना मास हो गया, और ग्रेविटी लगा दो, this is your force. तो the elementary work done should be how much? F dy, because I'm just taking this dy element up, उसको ऊपर ले जा रहे हैं, तो dy हो गया, force into the distance. इसको इंटीग्रेट कर दो to find the total work done. So you'll be getting the work done should be ओके लिमिट भी लगा दो, लेट्स पुट द लिमिट, बट फिलहाल तो मैं इसको पहले पुट कर देता हूं, लेट अस सी. सो m अपॉन l y और g you can write here dy, and you know that the y is changing from where to where, l upon n to 0, because once the entire chain is on the table, the hanging part should be 0. So this is going to be the work done. So the work done could be easily found out as m is constant, g is constant, l is constant. Inside what do we have is y dy, and the limit is upon n to 0. इसको इंटीग्रेट कर दो, सॉल्व कर लेंगे. So the total work done should be how much? Total work done should be m capital G upon L, और आपका हो गया y square upon 2. You should put the limit L upon n to 0. So that should be mg upon L. Capital मान लो because we have taken the entire mass as capital M, तो let's suppose capital M है ना. Okay, great. 2 should come out. We'll be having what? 0 minus L square upon n square. If I solve it, I should be getting what? Minus. अच्छा हाँ, एक मिस्टेक हमने यहाँ पे किया है. आप टोल्ड की dy इज द एलिमेंट्री पार्टिकल जो कि डिक्रीज हो रहा है ना, तो हैव टू पुट माइनस dy, इसको माइनस करना पड़ेगा. ये बात को याद रखना, क्योंकि एलिमेंट्री जो वैल्यूज ले रहे हैं वो डिक्रीज कर रहा है, तो डिक्रीज, तो वी हैव टू पुट अ माइनस. दिस इज गोना बी माइनस, यहाँ पे माइनस, ए माइनस. नाउ दिस माइनस माइनस शुड बिकम पॉजिटिव वैल्यू. हाँ, इसको आपको ध्यान रखना होगा जी, है ना. तो वी शुड बी हैविंग हाउ मच? m g, L square would get cancelled with L left and 2n square. So this is the work done by the force against the gravity to pull the entire chain on the table. Clear है? All good? बहुत अच्छा. So this should be the work done. Now quickly let us move on towards one more question where I'm going to talk about the spring, because spring force is also a variable force. The reason being it depends upon the displacement of the spring from its mean position. So अपने को भी देखना है एक क्वेश्चन, उस पर भी हम लोग देखते हैं. I believe you guys have noted it down. आप लोग फिर भी इसको नोट कर लो. Let's suppose I have a question that a spring is connected to a wall, and there is a force which is applied on it, which pulled the spring by a length of x. तो let's suppose it pulled the spring by a length of, let's suppose x naught. x naught से pull कर दिया, और जो final situation of spring है, it would get stretched and it would be here. यहाँ तक आ गया है ना. So there is a pull of, there is a stretch of x naught. The question is, find the work done. Find the work done by the force. Work done by F in stretching the spring, by distance by x naught. Let's suppose the spring constant is k. Spring constant is k. You guys give it a try. Meanwhile, I'm going to erase this part of the board. I believe आपको ये समझ में आ गया होगा. You should not have any issues with this. इसमें आपको दिक्कत नहीं होनी चाहिए. All good? Great. So the next question already you have on your screen. You can give it a try. बहुत बेसिक है, फंडामेंटल है. आई एम श्योर कि आप लोग इसको कर पाओगे. करो, फिर हम लोग साथ में करेंगे. ऑल गुड. ठीक है. So let us see that. Again, we know that when the spring is stretched, there is going to be a force opposite of the stretching, opposite of the extension. So there is going to be a force over here that should act in this direction, kx. If rightward, if I take positive, the leftward has to be negative. You can see that the force of the spring, which is given as F is equals to minus kx, अगर हम लिख लेते हैं इसको, that tells you that if this is the main position, तो अपने को पता है कि force है वो x के opposite में लगता है. So if I want to write that properly, I can say that F should be equals to minus of kx dash, kx है ना, which means the force is opposite to x. And it is proportional in terms of magnitude. F is proportional to x. जितना ज्यादा x होगा उतना ही ज्यादा force होगा, क्योंकि magnitude wise it is proportional to x and direction wise it is opposite of x. All good? इतनी बातें clear है बच्चों? True. लेट्स से दैट कि द स्प्रिंग मूव्ड बाय स्मॉल डिस्टेंस dx, एक छोटे से डिस्टेंस के लिए हम लोग मान लेते हैं, फिर से वही, बिकॉज दिस फोर्स इज डिपेंडेंट अपॉन द x, सो इट इज अ केस ऑफ अ वेरिएबल फोर्स वेयर द फोर्स डिपेंड्स अपॉन द x, और जहां पे वेरिएबल केस आ जाए, एक एलिमेंट्री पार्टिकल लो, छोटा वर्क निकालो, इंटीग्रेट करो फॉर द एंटायर, बस यही करना है ना, ऑल गुड. So I'm going to find the small work done for the small displacement dx. So dw should be how much? F dot dx, और इसको इंटीग्रेट करने से अपने को पूरा का पूरा फोर्स वर्क डन मिल जाएगा. ऑल गुड. Now this force is given in how much? Minus times of kx. This displacement, let us be kx, and we know that this x is happening from where to where? At the main position, there is no displacement, no extension, no stretching, so value of x should be 0, and from there it is happening to x naught. So minus k is going to be out. Integration of x is going to be x square upon 2. Just put the limit from 0 to x naught. That is going to give you minus k upon 2 x square minus 0. So that is okay. So work done over here is going to be minus kx square upon 2. Well, this is the work done by the spring force. मैंने क्या पूछा है? Work done by F. है ना जी? Now this is also a very important result. अगर मैं चाहता तो इसमें पूछ सकता था work done by the spring. उसका आंसर है. So this is the work done by the spring. आप इसको गलत मत लिखना. So this is the work done by spring लिख दो. Work done by the spring अपने इतना हो गया. Same question since they have asked me work done by the force. Now you can see that force is acting towards right, displacement भी right में हो रहा है, तो उसका साइन पॉजिटिव होगा, पॉजिटिव वर्क इज डन, वैल्यू शुड बी सेम, वैल्यू सेम ही आएगा, बट इन दिस केस इट इज गोना बी हाफ kx स्क्वायर. कोई दिक्कत नहीं है, इसलिए रादर गिविंग यू दिस आई शोड यू कि इतना ज्यादा आपको पता होना चाहिए. करेक्ट है ना? ऑल गुड. दूसरी बात, इसमें हम और भी बाद में चर्चा करेंगे कि हाउ इट इज अ कंजर्वेटिव फोर्स, तो अपने आप को ये एडजस्ट करके वहां पे वो काम कर रहा है. तो इफ यू पुल इट, देयर शुड बी सम फोर्स दैट शुड अपोज इट, एंड दैट इज अ स्प्रिंग फोर्स, और बिकॉज ऑफ दैट ओनली अपने को कुछ काम करना पड़ता है बाय द एक्सटर्नल एजेंट फॉर द वर्क टू हैपन. ठीक है जी, ऑल गुड, फेयर इनफ. Okay, let me give you one more situation. Let us do one more question. We have time, we can do that. Let us assume that spring and the inclined plane is related in this way. Let's suppose there is a spring and it was connected to a block of mass, let's suppose m. In equilibrium, this is the case. So in equilibrium, there should be some compression at equilibrium. There must be some compression at equilibrium. Spring is compressed. क्यों compressed होगा बच्चों? Because the weight of this block due to the inclination would try to pull it downward. इसके weight का कोई component इसको along the plane downward pull कर रहा होगा, so there should be a force, and spring is going to oppose that because spring is now compressed. Spring इसको oppose करेगा and this is going to be in equilibrium. तो मैंने आपको इक्विलिब्रियम का एफवीडी बना के देता हूं, आप बाकी का काम आप करोगे. ओके, सो दिस डेफिनेटली इज नॉट द नेचुरल लेंथ. इसका नेचुरल लेंथ नहीं है. दिस इज नॉट द नेचुरल लेंथ. ये आपका नेचुरल लेंथ नहीं है, क्योंकि नेचुरल लेंथ शुड हैव बीन थोड़ा सा और ज्यादा. तो दिस इज अ कंप्रेस्ड लेंथ. ये कंप्रेस्ड लेंथ है आपका, है ना. इट्स mg डाउनवर्ड. वन फोर्स along this is going to be mg sin theta, and we should have the normal. As of now, I do not have any friction. Coefficient of friction मान लो 0 है. It is a case of smooth surface. So these are the forces acting on it, and due to this compression, there should be a force that would act along opposite of it by the spring. Spring के कारण होगा, which is minus of kx. देखो माइनस क्यों आता है, मैंने अभी बताया है कि डिस्प्लेसमेंट इस केस में स्प्रिंग का जो कंप्रेशन है, ऑलरेडी मैंने न्यूटन लॉज ऑफ मोशन में सब बातें डिस्कस कर रखी है. अगर आपने वीडियोस नहीं देखा है एंड इफ यू वांट टू रिवाइज न्यूटन लॉज ऑफ मोशन, यू आर मोस्ट वेलकम. आप जाके देखो, आपको समझ में अच्छा आएगा. सो नाउ लेट अस से दैट द फोर्स इज गोइंग टू बी इन दिस डायरेक्शन. द रीजन इज माइनस क्यों है, क्योंकि स्प्रिंग इज कंप्रेस्ड और इसका फोर्स उसके ऑपोजिट लग रहा है, इसलिए हम इसको माइनस से दिखाते हैं. इन टर्म्स ऑफ मैग्नीट्यूड वो kx ही होगा, उसमें तो कोई डाउट अपने को है ही नहीं. So at the equilibrium, this is the entire situation. अच्छा, let us suppose कि this force, okay, इस force spring force है ना, तो इस पे एक force लगाया गया so that the body goes from here to here. आराम से वो slowly चला जाता है. How much force should be applied? और कुछ फोर्स लगाया गया दैट शुड मेक द बॉडी मूव स्लोली, एक एक्सटर्नल फोर्स लगाया गया सो दैट द बॉडी मूव्स स्लोली। तो जस्ट टू रिप्रेजेंट इट मैंने दिखाया था, मैं इसको हटाता हूं जस्ट टू अवॉइड एनी कंफ्यूजन, ताकि ज्यादा इसमें डायग्राम में कंफ्यूज ना हो। लेट अस सपोज वी हैव अप्लाइड अ फोर्स F, F moved the body slowly, moved the body or the block slowly back to its normal, slowly, so as to have the spring in its normal length, normal condition, मतलब स्प्रिंग में कोई स्ट्रेचिंग नहीं है ना, नॉर्मल कंडीशन, नॉर्मल कंडीशन। क्वेश्चन इज फाइंड द वर्क डन बाय द फोर्स, फाइंड द वर्क डन बाय फोर्स F, F कितना काम करेगा, इसको वापस से नॉर्मल पोजीशन में ले जाने के लिए आपको वही निकालना है। ऑल गुड, एक काम करो, try this as a homework, try this as a homework. In the very next video I'm going to first discuss about this and then I'm going to take you towards the conservation of energy. All good, तो ठीक है, that's it for the for this day. I'm going to see you in the next video. Till then keep studying and keep learning, okay, and do not forget to like and subscribe if you do like the way I teach. All good बच्चों, तो मिलते हैं next video में, take care, thank you.